Hey, what's up everybody? Welcome to the 25 SAT Math Concepts Summary video. And today we are going to do trigonometry. So here is every single trigonometry concept that you need to know in order to solve any question on the SAT Math. Alright, so first we are going to see trigonometric ratios of acute angles. Second, you need to know complementary angle theorem. And third, you should know about trigonometric identities. So let's get started. So I'm going to draw a right triangle. Wow, that's neat. Okay, and let's say that we have this right triangle A, B, and C. This is of course the right angle. And I'm also gonna say that this angle is my theta, and this side has length C units, this is A units, and this is B units. So first we will see the trigonometric ratios. So we are going to see what is sine of angle theta. So sine of angle theta is nothing but the ratio of the opposite side. So this is theta, so opposite side is BC. Opposite side is BC. So I'm going to write here opposite and hypotenuse. Cosine is equal to length of the adjacent side. So adjacent side is AC. So first I'm going to write adjacent over hypotenuse. And your tangent of theta is the ratio of opposite side over adjacent side. So your sine of angle theta is going to be opposite is A, hypotenuse is C. Cosine of angle theta is going to be adjacent. Adjacent is B, hypotenuse is C. And tangent is the ratio of opposite and adjacent, so that is A over B. And if you notice one thing from these three equations, your tangent is actually nothing but tangent. If you see, it's the ratio of A over C and B over C, or it's the ratio of sine theta and cosine theta. So this is again a very useful identity. Okay, so this completes trigonometric ratios of acute angles. Second, we have complementary angle theorem. So complementary angle theorem says that your sine of theta is equal to cosine of 90 minus theta. Obviously in a right triangle, and cosine of theta is equal to sine of 90 minus theta. And if in a question it's given that sine of angle A is equal to cosine of angle B, then your angle A plus angle B will be equal to 90 degrees. So this is everything that you need to know about complementary angle theorem. Okay, and lastly we have trigonometric identities. So although there are many trigonometric identities, I am just going to focus on the ones which are tested. So the trigonometric identities, first one I've already written, that tangent of any angle is the ratio of sine of that angle and cosine of that angle. So sine of theta over cosine of theta, that's the first identity. And the next identity that you should know is sine square theta plus cosine square theta is equal to 1. These are the only two identities that you should know. Well, actually there are a couple of more identities, and there is some more stuff that you should know, but it won't be possible for me to cover everything in one video. So I'm just gonna taking those concepts which have 90% chances of being tested on the exam, but still this video does not cover the rest of the 10% topics that could be tested, but those 10% of the topics have less chances of being tested on SAT Math. Anyway, now we're going to do some questions based on the concepts that we have learned. So first we see here that here there is a figure, angle x is there, angle y is there, and it's been given that y is less than x is less than 90 degrees. And it's also given that cosine of x is equal to sine of y. So the first thing that we can tell from this relationship that cosine of x is equal to sine of y is we can say that measure of angle A plus, measure of angle x is equal to measure of angle y. My bad. We can say that measure of angle x plus measure of angle y is equal to 90 degrees. This is what we can say. Now it's also given that x is equal to 3a minus 14 and y is equal to 50 minus a. Then we have to find out the value of a. And now we know that there is a linear relationship between angle x and angle y, which is angle x plus angle y is equal to 90 degrees. So all we gotta do now is substitute the values of angle x and angle y. So x is 3a minus 14 plus measure of angle y is 50 minus a. This is equal to 90 degrees. And now this is a linear equation that we can solve. So 30, first I'm going to open the parentheses, 30 minus 14 plus 50 minus a is equal to 90 degrees. 30 plus 50 is gonna give us 80. Oh, I'm so sorry, this is not 30, this is actually 3a. I'm really sorry. So this is 3a minus 14 plus 50 minus a equals 90 degrees. Now 3a minus a is going to give us 2a plus 50 minus 14 is going to give us 36, and this is equal to 90. So 2a is equal to 90 minus 36. 90 minus 36. So 2a is equal to 54. And that means a is equal to 54 divided by 2. That is nothing but 27. So value of a is 27. Right, let's take the next problem. So here we have a triangle ABC, and here you can see that angle A is equal to 34 degrees, and this angle is a right angle, and we need to find out the value of, and AB is equal to BC, and we have to find out the value of sine of angle CBD. So sine of angle CBD, which is this one, minus cosine of angle BAC, which is this one. Alright, so let's see what we have over here. So it's been given that AB is equal to BC. That means that triangle ABC is an isosceles triangle, and if this angle is 34, so this angle will be also 34, because opposite angles of isosceles triangle are congruent. So this angle is 34, and since this is a right angle, so this is also gonna be a right angle. Okay, and then whatever this angle is, the same will be this angle, because this is 34, this is 34, this is 90 degrees, this is 90 degrees, and since sum of the three angles is 180 degrees, so these two guys also have to be congruent. So now if I see in triangle BAD and triangle BCD, side AB is congruent to side BC, and your angle A is congruent to angle C. So I'm just gonna write this: angle A is congruent to angle C, and side AB is congruent to side BC, and this green angle, I'm just writing like this is also same as the green angle. So these two triangles are congruent. They are actually congruent by angle side angle congruence theorem. So if they are congruent, then that is gonna mean that all the congruent parts of these two triangles will be also congruent. So we can say that this AD will be congruent to DC. Alright, now let's see what we have to find. We have to find out sine of angle CBD minus cosine of angle BAC. So sine of angle CBD, if you look at this right triangle CBD, sine of angle CBD is gonna be, so sine is equal to opposite side which is DC, right? For angle CBD, the opposite side is gonna be DC over the hypotenuse, which is BC, minus cosine of angle BAC. So now if you look in the triangle BAD, so your angle BAD will be same as angle BAC. So cosine of angle BAC is going to be same as the adjacent side, which is AD, over hypotenuse, which is AB. And so DC and AD, now just look at the numerators, DC and AD. We have just concluded that DC and AD are going to be congruent, right? So they are going to be congruent. So I can write DC in place of AD, I can write DC. And BC and AB, it's already given that they are congruent. So basically this sum will be equal to 0. So that's it for this video. And actually in this particular question, if you see, can you just write in the comments that what all concepts did we use in order to solve this question? Just write the names of the concepts that we used in this particular question. Now that's it for this video, and remember that it does not cover all the question types which can be asked on SAT Math from trigonometry, because I can only cover so much in one video. And I think, yeah, that's it, and I'm gonna meet you in the next video. Till then, all the best.